Okay, homework 24 is basically the same as 23. It's more examples of implicit differentiation, so nothing brand new. This is our last homework of the chapter. Chapter 3 is basically about just doing a derivative. We're not actually applying it to situations. Okay, first we're going to look at this equation here. It wants us to find the first derivative. You'll notice that there are x's and y's in the same equation. Okay, and when we do this type of derivative, really what we're doing is dx. So we're doing a derivative where x is supposed to be the variable. So when we get to this piece, we're going to have a problem. We're going to have to do the chain rule. So here we go. The first piece, the derivative for sine, is just going to be cosine. And then we say, wait a minute, it's not just an x, it's an x squared. So we're going to have to do the derivative of x squared, and that'll give us a 2x. I'm going to put the 2x in the front. And I do that so that people understand that the 2x is not part of the angle. Only x squared is part of the angle. We'll copy down the minus. What is the derivative for cosine? We would get negative sine. And then we say, wait a minute, it's not just an x, it's a y to the third. So we're going to have to do the derivative of y to the third, and that would be 3y squared. And we have to say, wait a minute again, because it's not an x, it's a y. So I'm going to have to do the derivative of y, and that will be y prime. Okay, on the other side of the equal sign, we have a 1. The derivative of 1 is just going to be 0. If you look at the original question, it says find y prime. So here's our y prime. It's sitting right here. So we just need to solve this for y prime. You'll notice we have minus a negative, so that's going to be a plus. I'm going to go ahead and move this to the beginning here. Now I'm going to want to subtract this from both sides. Again, I'm still trying to solve for y prime, which is right here. So all I need to do is divide both sides by all this stuff right here. Okay, all of this stuff right here is going to cancel. And we're left with y prime equals this fraction right here. And that's it. Okay, up until now, we've pretty much done the derivative with respect to x on pretty much everything. But now we're going to look at doing the derivative with respect to t, which is usually time. So we have this circle right here. A lot of times we'll have an example where you drop a pebble in a pond and the circle is getting bigger and bigger and bigger, but you see it's changing with time. So we want to see how something changes with respect to time. And so we're doing this derivative with respect to t on this example. Now I want you to notice none of these letters are t. So every time we do the derivative, we're going to have to do the chain rule. And so we're going to get an extra prime. Let me show you what I'm talking about. Normally, when I do d dx of x squared, it's just going to be 2x. But because I'm doing d dt of x squared, I'm going to get 2x, but then I'm going to get an x prime piece. And that x prime is really dx dt. It's another way of writing it. So it's not going to equal 1. And the same thing is going to happen for this letter, and the same thing is going to happen for this letter. Now what's weird about this one is that the radius of a circle is usually constant. In this case, like I said, we dropped a pebble in a pond, so the radius is actually changing as time changes. The radius is actually getting bigger. So when we do the derivative of this, we're not getting 0 like we normally would. Normally that's a constant, so when we do the derivative of a constant, we normally get 0. In this case, we're not. So let's have a look. d dt of each of these pieces, we're going to get 2x and then x prime. The derivative of y squared is going to be 2y and then y prime. The derivative of r squared is going to be 2r and then r prime. Again, it is asking us to find x prime. And x prime is sitting right here. If I was going to solve for x prime, what I would probably do is start by just dividing everything by 2. That's the same thing as if you multiplied everything by 1/2. You would get x prime plus y prime is equal to r prime. Now let's get rid of this. We'll subtract that from both sides. And the last step is just to divide everything by x. On the left side, the x's will cancel. Again, the reason why x over x can cancel is because we're saying x cannot be 0. We're dealing with the equation of a circle, and it wouldn't be a circle if x was 0. Okay, after canceling the x's, we get that x prime is equal to this fraction right here. And that's it. Okay, on this example, you can see that we have a function to a power that's also a function. They want us to do the derivative, but we don't have a rule for the derivative of that. So we're going to have to do ln of both sides in order to get the x to come down. Let's have a look. Okay, again, we're just rewriting it. We're not doing calculus right now. Because we have ln of something to the power of x, the power of x can come down. We'll bring it down right here. Now we can do the derivative of both sides. On the left side, the derivative for ln of x would be 1 over x. So here we're getting 1 over y. But it's not an x, it's a y, so we have to do y prime. So we can do the first times the derivative of the second plus the second times the derivative of the first. Okay, this derivative is just going to be 1. This derivative is the tough one. We're going to get 1 over cosine times the derivative of cosine. Okay, again, we're solving for y prime, so we just need to get rid of that 1 over y on the left side. We can multiply both sides by y, and then we're done. On the left side, all this stuff cancels, and we just get y prime. You can write sine over cosine as tangent. But the problem is we cannot leave the y right there. We have to trade the y for what the y is equal to, and at the top it says y is equal to cosine of x to the power of x. Okay, so let me move this stuff up. Again, we're going to trade the y for cosine of x to the power of x. And that's it. That's your final answer. Okay, here they want us to find the derivative and then plug in 1, 1. So we're going to plug in x equals 1 and y equals 1. Notice they want us to do d dx. So we're doing the derivative with respect to x. So anytime we do a derivative of something that has a y, we're going to have to put a y prime piece on there. Again, this is the quotient rule. Okay, derivative of the right side is pretty easy. Derivative of x just gives you 1. It's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, we have two derivatives that we still have to do, this one and this one. Okay, for this derivative right here, derivative of 5x is going to be 5. The derivative of 3y squared is going to be 6y, and then y prime. For this derivative over here, the derivative of 9y to the third is going to be 27y squared, and then y prime. And the derivative of minus x squared is just going to be minus 2x. Now, we are solving for y prime, but I don't recommend you doing anything right now until you plug the 1, 1 in. So this is going to be kind of like my trick to make things easier on you. You can plug the 1, 1 right now. So every x you trade for a 1, every y you trade for a 1. We're not going to be able to touch this, and we're not going to be able to touch this. But everything else, you plug a 1 for the x and a 1 for the y. This is kind of a trick to make things easier. Okay, let's have a look. Let's move that up. Okay, if I plug in the 1, I'm going to get 9 minus 1, and then 5 plus 6y prime minus 5 plus 3. And then 27y prime minus 2. On the bottom, I'm going to get 9 minus 1 squared. This is going to make things way easier. Let me move this up. We'll continue to simplify. Again, we do have to solve for y prime, and that's because it says find y prime. Our answer is going to be y prime when x is 1 and when y is 1. So we have a y prime right here. We have another y prime over here. We'll continue to simplify. Okay, then we can distribute the 8, and we can distribute the negative 8. Okay, moving that up. We continue to simplify. Okay, let's move that up, create some more space. Okay, we have an equation, so we can get rid of the 64 if we just multiply both sides by 64. So this 64 here cancels with the 64 on the bottom. And on the right side, we get a 64. We want to collect like terms, so the 40 plus the 16 gives us 56. We want to combine the y primes. So 48 minus 216 gives us negative 168 y prime. Let's move this up. I'm going to subtract 56 from both sides. This will cancel. You get negative 168 y prime. And on the right side, you get 8. Okay, again, let's move this up. We're going to divide both sides by negative 168. And now we're done. This is our final answer. We can still simplify. This is 8 times 1. And this is 8 times negative 21. So after canceling the 8's, we get negative 1 over 21. Now right here, this is not the best notation, so let's try to fix that. Because we plugged in the 1, 1, we really should write that this is y prime of 1, comma 1. Especially if this was a free response question. And that's it. Okay, last example, they want us to find the second derivative. Notice we're doing this type of derivative, d dx. So whenever we're doing the derivative of something with x, it's really simple. But when we do the derivative of something with y, we're going to need to put that extra y prime piece. The right side is really easy. The derivative of 2x squared, well, the 2 comes down and gives you a 4, and the new power is 1 less. So it's power 1. The derivative of x is just going to be a 1. So that was really easy. The derivative of the other side, remember we're doing d dx. And these are y's. So we're going to get that extra y prime piece every time we do the derivative of something with a y. So for y squared, the derivative will be 2y, but then we have to put y prime. The derivative of 3y is just going to be a 3, but then we have to put y prime. Now we can factor out the y prime, and we would be left with 2y plus 3. Okay, we have one more step to solve for y prime. We're going to divide both sides by 2y plus 3. So all this stuff is going to cancel. Our final answer is that y prime, which is right here, is going to equal this fraction. Okay, let's erase this stuff. Because remember, we're doing the second derivative. We found the first derivative. So we're going to have to do one more derivative, and you can see the derivative is going to end up being quotient rule. Okay, here we go. Second derivative is going to equal the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, let's do this derivative here. The derivative of 4x plus 1 is just going to be 4. Remember, 4x plus 1 is just a line. It's like y equals mx plus b, so the slope is just going to be the m, so it's just the 4. Now let's do this derivative here. The derivative of plus 3 is just 0, that does nothing. The derivative of 2y is going to be 2, but it's the wrong letter, so we're going to have to put y prime. Now we're basically done, except we're going to have to trade this y prime with whatever it says over here. It says y prime is 4x plus 1 over 2y plus 3. So we'll plug that in and then we'll be done. Okay, let's move this up. Again, we're trading this y prime for what y prime is equal to. So that's going to be this fraction right here. Let's plug it in. Now you could simplify this further, but we don't have to find the third derivative or anything like that. So I would just stop right here and leave this as your final answer. So there we go. That's our second derivative.